Welcome to Radian Measure. This is an A-level mathematics topic taught on the Core 2 syllabus. Now the aim of this video is to make the connection between radians and degrees. Now my explanation of the technique used here may seem a little bit drawn out, but I do need to make sure that the flow of logic is 100% clear to you. So please grab a pen and paper, pause or fast forward the video as required. So why radians? Well, radians are an alternative way to measuring angles. I know, not another measuring device that is required, and what on earth are radians? But trust me, okay? At the study of A level or other higher qualifications, we generally prefer radians instead of degrees. Radians make measuring more simpler and are preferred more mathematically. Now, of course, common sense here would have to take place, and it's knowing when to use radians and when to use degrees. So, for instance, if I had a crane driver, and let's say I asked that crane op to set the crane at pi radians over 4, well, that just seems silly and very confusing. If anything, you would just say set your crane to 45 degrees. So like I say, it's knowing when to use radians and when to use degrees. So what are radians? Well, I'm glad you asked. Radians are related to the radius of a circle, and do note that radians and radius sound the same. If we take a full circle with a radius r, and let's look at the definition. It states that 1 radian is the angle subtended at the center of a circle by an arc whose length is equal to the radius of a circle. Sounds very confusing, and it would be no difference for when I was there, but basically it's just arc length that we are looking for, and we need to make this connection between radians and degrees. And to do that, let's go back to GCSE work where we worked out arc length, and it was this fraction of the circle being theta over 360 times 2 pi r, which 2 pi r being the circumference of the circle. And that connection is how many of these arc lengths would fit right round the circle. So we need to look at the number of arc lengths which would equal the circumference over the radius. Now, we already know the circumference. It's 2 pi r divided by the radius, which will cancel out to just give us 2 pi. Now, we know that 2 pi now is the equivalent of going full round the circle, but if we take pi to being 3.14 and times this by 2, we get 6.28. So that's really saying that this goes round 6 with 0.28 left over, or 28% of it, but I like to use the word just a little bit left over. So it's not quite the whole thing that we need. So we are allowed to use key facts that we know. And we know that a full circle is 360 degrees. So now we can use that to define our relationship between radians and degrees. So we can say, therefore, 2 pi equals 360 degrees. And that's our relationship. 2 pi equals 360 degrees, or 2 pi radians equals 360 degrees. And from here, we can now derive to many more facts with radians and degrees. So for instance, the easiest one would be a straight line or half a circle. So we divide both sides by 2, then pi equals 180 degrees. And using that in terminology to radians, we normally would say 2 pi rads or 2 pi radians equals 360 degrees. So pi rads equal 180 degrees. Now, in terms of bringing that into our arc length, we can actually see that if we had 1 radian, what is that radian really connected to? Well, I can actually divide that by 180 to find that. 180 divided by pi would give me an equivalent to 57.3. Now, of course, I could have used to find 1 radian would be 360 degrees divided by 2 pi. Either one that I use would give you 57.3. So it's an approximation to that. Because of course if we multiply that by 6, you would see that that would be over 360 to 361 degrees, which is not quite a full circle. So we can relate this back to our definition in a more simpler terms, that 1 radian is the angle subtended by the arc of length r, where r being the radius. So now we've made that connection, and I'm sure that was quite a lot to take in and a bit confusing to you, and it's bound to be because it's new. Let's now define radians as in symbolizing a word rather than writing words like radians and rads. Now symbolizing radians. In mathematics we like to use that C, where it's C symbolizes radians. Now in the past students have said to me, well, why not R? Because that's easier to use. Well, R is being used for obviously radius and radians, so we use that C, which symbolizes the arc. Okay, so the reason why an arc is used to symbolize radians measure is because that's exactly what radians means. It is actually the arc length of a unit circle. Now, using RC to denote radians, and please when you are doing this, do make sure it's a C and not a closed one to get confused with degrees. So please make sure your C is well known. So going from what we do know, a full circle being 360 degrees, well, that's the equivalent to 2 pi radians in this case. So halving that, we would get 180 degrees equals pi radians, and then halving that again, we would get 90 degrees equals pi radians over 2. Now, I'd like to visualize that as in a 180 degree straight line with a perpendicular bisect right in the middle, giving us 2 equal 90 degrees. Likewise, halving 90 degrees, we get 45 degrees, giving us pi radians over 4. And to visualize that, I like to look at my 290 degrees there, splitting that by a 45 degree to give me then 90 degree, then to give me 135 degree, then of course finishing off at 180. And 180, okay, divided by 4 would give me 4 equal angles there, which is 45 degrees. Hence giving us pi radians over 4. Then of course I can see 360, 180 and 90 is divisible by 30. So pi radians over 6. And to visualize this technique, again I would have a 30 degree, followed by 60, followed by 90 degrees, followed by 120, 150, and then of course 180. So giving me 6 equal angles. So 180 divided by 6 would give me 30 degrees. So therefore that's pi radians over 6. Now you don't need to memorize all them. The first two of 360 equal 2 pi radians, and then of course pi radians being 180 is good enough to use to work out any other facts. Now of course we are expected at some point to convert degrees into radians, and that could be 60 degrees, it could be 120 degrees, it could be 135 degrees, we could be asked to do 210 degrees, we could be asked to do 70 degrees, or we could be asked 225 degrees. And what you should really notice, what I'm looking for here, is everything on that right hand side is pretty much divisible by something on the left hand side to help us with that conversion. Now of course for the first three, I'd like to use a visual aid to give us that idea of where we convert to these. So let's look at 60 degrees, and using a full complete circle here from 0 degrees to 360 degrees, and I know 60 degrees is divisible by 30. So how many 30 degrees can we fit in? Well, it's going to go once there, but we also know that that is the same as pi radians over 6. And we can see that 60 degrees, okay, will go there twice. So it's gone once, twice. And I'm allowed to state that 60 degrees is equivalent to 2 pi radians over 6. Now, of course, here I do encourage you to cancel down, and of course that will give us pi radians over 3. Now 120 degrees, I can also see this divisible by 30. So since I've started with a model of 30 degrees, we can continue with 90 degrees and 120 degrees. And of course, we can see that this has gone once, twice, 3 times, and 4 times in there. So I can actually write 4 pi radians over 6. And like we did previously, cancel down. So this would be the same as 2 pi radians over 3. Now 135 degrees, well, that's obviously divisible by 45. So using my model for 45 degrees, I would see that I would get 45 degrees at this point, knowing that that's pi radians over 4. Then we've got 90 degrees, then I've got 135 degrees. And 45's gone once, twice, 3 times. So I can actually state that 135 degrees is 3 pi radians over 4, or 3/4 pi radians. Now, what do we think about 210 degrees then? So the obvious one is 30 degrees. How many 30s will go into 210? Well, it goes 7 times. So this is just going to be 7 pi radians over 6. Now we come to 270 degrees. Now there are a few here you can actually use. If you use 30 degrees, we can see that 30 goes into 270 9 times, giving us 9 pi radians over 6. But both of them will actually cancel down to giving us 3 pi radians over 2. Now, of course, you could have used 45. That will give us 6 pi radians over 4, but 6 pi radians over 4 will cancel down again to 3 pi radians over 2. And of course, the more easiest one there to have used, if you look at 90 degrees, 90 is going to go 3 times. And we can see that we've got 90 degrees is pi radians over 2. So going 3 times will give you 3 pi radians over 2. That was the quick and easiest one to use out of them. And of course, finally, 225 degrees, well, 45 degrees is going to go back into that one yet again, and that's only going to go 5 times. So this will give us 5 pi radians over 4. So I hope that was much easier for you to understand. We will look forward to seeing you again when we actually do radians using arc and sector area, and of course working from the formula, and that you will find much easier to use. So for now, stay safe and take care. Thank you for listening.